Okay, good morning, everyone, ladies and gentlemen, both the people who are on Zoom, including people from other side of the world, and then we've got a bunch of obviously local people. I'd like to introduce the two speakers. Jean Malan is a geologist. He studied at the University of Stellenbosch. He's an expert on our local marine geology. He did a thesis MSc on the blast geology. If you go for a walk along the beach next to the Kelders, you'll see some wonderful examples of big mega dunes of younger than 2 million years. And that's his field of expertise. He's also had a wonderful career in the oil and gas field. And if you want to speak to an expert about oil and gas, there's the person. And John's been involved on some very major offshore seismic activities, seismic profiling, which we all hear about in the press, and working around our coastline. And the sort of work that he does, typically those surveys would have cost tens of millions of dollars, not rands. And the sophistication and what has always struck me is the care for marine life, be it a bird or a whale or whatever. When you stop those surveys because a bunch of porpoise or whale comes into the area, and that's very rarely, you stop the whole show, and that costs you millions of or hundreds of $1,000s an hour for every line kilometer that you're not surveying, or because you've now stopped the survey. But that's also for another discussion, and he's done some lovely talks previously on that. Okay, and then our second speaker is Ian Flint. Ian, again, is a local. John lives in Claremont. Ian is a local. He lives here in Hermanus. Ian started life as a botanist zoologist, so he also knows about the birds and the bees and the animals that live on this earth. And then he became a successful businessman and entrepreneur and ran businesses in Cape Town. And he's now part of the local group, one of our members and a great asset to this community. So thanks everyone, and over to you, Jean and Ian.
Thank you, John. And Ian, let's just join everybody on the screen first. So as an introduction, so our title, what was given to us a couple of weeks ago, was How Fossil Fuels Saved Life on Earth and Should Be Allowed to continue to do so. This is a series of a couple of talks, and it's probably the last one, which was started a couple of months ago by Andrew. It was followed up by Ian, and I was brought in by the team to talk about the geology side a bit more than was previously addressed. The content of the talk is, and it will be split between Jan and myself. I lead in the geology bit. And when it comes to geology, we step things back to the age of time, so to say. But what we're going to share with you is some opening statements, definitely going towards the oil side and specifically carbon dioxide and CO2 and its role through Earth's 4.6 billion years of history. One of the drivers forever was a wandering Earth, as I put it there, continental drift. Touch base on that. And then it's an engine, the Earth. It's got internal heat sources, and there's also external sources. And between Jan and myself, we'll touch that. And then bang, overriding many of those are climate change. And that is what is being put out there in big, bold numbers, whether it's in the New York Times, the Burger, or BBC, is climate is changing and carbon dioxide, CO2 is to blame. And where does CO2 come from is humans, and it's because us, are burning fossil fuels, whether it's coal, whether it's petrol, whether it's in our cars, diesel, etc. So we'll touch that, the climate change, and then really over to Ian in a stage as well about the other side of the coin. because we're putting out the fossil fuel side. And so Jan will touch base on that for us, and he calls it the green lies and propaganda. And then CO2 as a savior of Earth, and why and where we got so close to the point of actually nearly strangling the last oxygen and the last CO2 on Earth. And then, okay, if time allows, I'm going to take you closer to home, straight to our offshore here, where in the last week or so, there was an announcement of 5 oil wells due to be drilled offshore Hermanus in those areas. So that's that one. Opening statements, some of this our own, some of this from Anthony and others, but because oil and natural gas so effectively provide power, fuel vehicles for reliable transport, heat homes, pump water, and form the basis of plus 6,000 petrochemical items and products. We thrive, that's a fact. If we haven't had the benefit of fossil fuels and where the industrial revolution stage took on and progressed to today, Earth wouldn't have been where it is today. Okay, part of that is population growth, prosperity, etc. But I say, thanks to fossil fuel, we've got this amazing productive ability, and the only reason we experience the planet as livable as today. There's quite a few advocates of the same, and I've just got one guy out there, Alex Epstein, and he says the core value in human living is to thrive, and to thrive we need energy, right? The trend in geological time, and you'll be shared with that in quite a few diagrams, is there has been a trend and a decline in carbon dioxide. So we'll share that with you.
Don't click anywhere on the screen.
Anyway?
Yeah. No, not on the slide. Just on your screen. Get that away.
Yeah, okay. Zoom screen. Oh, boy.
You can't use that for the right. Drag it on. Drag it. Drag it. Use your cursor. Pause the recording for a while. Why will there about half a second delay between screens?
Sure.
Slides, okay?
Sure.
Right, there we go.
Right. And for carbon dioxide is in decline. We share that with you, and it reached a very dangerous low level. And then it's not unreasonable to suggest that burning fossil fuels, and I'm a petroleum geologist, and I've been drilling for oil, I've been producing oil, etc. It's helped to restore CO2 to a safer level, to a biologically more productive level, so to say. And Jan will hit that for us. And then the benefit of increased CO2 outweighs the negative of what we see, the current mild warming period we're experiencing. And we'll share some of that with you as well. Right, quickly, how do you cover 4.6 billion years in 2 slides? I'm going to do it without going into detail, but way back, 4.5, 4.6, at the start of everything, there was no oxygen. And then in the beginning, the surface of the Earth plus 500 C was filled with radioactive elements and heat, but plenty of them were decaying. And then by about 3.8, let me just get a mouse over here. Oops, don't touch that. We started to form the crust, but in that process were these massive volcanic outpourings, water vapor all over, etc., with CO2 and methane escaping. But slowly seas started to form, oceans, seas, and clouds and rain and sediment getting washed off. So by 3.5 billion single cells, algae, I'll share some of that to you just now, appeared, and the conversion by photosynthesis started, and vast volumes of carbon dioxide were gathering. The generation of that gathered momentum. Igneous activities continues, etc. Locally, for instance, we had the Cape Craton as a stable area in our area, the bigger Gauteng and all of that. From those days, it was already controlling South Africa, not only today, you know. So, but sediments were accumulating on the edge of the craton, and further basaltic outflows happened. Just one slide, taking us back to a period 3.5, 3.2 billion years, and that was the Barberton area. And you can see, again, why is this in our way here? Any? Can't we switch this off? More? It's stuck on the screen. More? Yeah, that's what I'm going to do. Leave. If it gives me...
Do not leave the meeting. Cancel.
I mean, this is really irritating for you. I apologize. Okay. Yeah.
Okay.
Right. So in the case of Barberton, ages out there 3.5 to 3.2, and it's seen as, and this is proven by microbial mats and evidence of ancient rivers in those as probably the first or earliest signs of life. And it was these microbial mats, and that started also evolving. And so, as listed there, is probably one of Earth's first ecosystems, way in our Barberton areas. What is interesting, as we speak, there's a big drilling program happening, a big research program that's been funded from multiple universities and institutions to, again, confirm all of that for us. Right, now we need to get to the next slide. So just stepping earlier to about 2.4, then to 500 million, there was these great oxygenation events, and I'll show you an example or two shortly. And also, there was so much carbon dioxide, CO2 being dumped into oceans and seas, and those releasing then life-giving oxygen by algae generated photosynthesis. Oxygen became freely available at 2 billion, and thrown into all of that, of these cratons, we had sea going up and down, but that's one thing. But the other thing clearly was our glacial periods. We'll touch that. But, okay, we're now stepping into look into carbon dioxide in the younger period of time. That's the Cambrian. So pretty much the top little section that, okay, don't do that. All right. Crucial, and this at give or take 2.2, 2.4 billion was banded iron formations, big oxidation events. And the occurrence of these red beds indicated that there was sufficient oxygen becoming available. Why? Oxidizing iron ore had rusted into its ferric state, as when looking at rock sediments before that, they were quite clean and white looking. So, right, just some local examples there, and with of banded iron. I mentioned oceans filled with also carbon dioxide. And two examples there is these massive limestone deposits, and top left to you is from Devonian reefs. And then what I've got at the base, and that's where I did field work quite a few times, was in Ethiopia, and that's the Anatola limestones. So we're looking at Devonian, and then those limestones forming those impressive mountains is Jurassic Cretaceous age. And again, just some examples. If you really look at the rocks there, you can see coral framestones, that's top left, as well as these lovely coral heads. And then finally, we've got these ammonites all over. Right, getting closer to home then is, and Mike and myself were out there a couple of weeks ago, was up in the Northern Cape on the border with Namibia. So Southern Namibia, Northwestern Cape, it's referred to as the Port Nolloth Group, but it's extensive dolomitic limestones, and you can see the mountain of it and close up, as well as this then gets overlain by what you see on the right is a glacial event. So the features in there are drop stones or material that's been brought along by glacials and ice. All of that happening about 720 to 650 million. Right, let's get younger in age, and what you've got on the screen there is at the beginning of, referred to geologists as the Cambrian era, so that's pretty much 540 and younger. I plot for you essentially one thing, and that is CO2, carbon dioxide concentrations in parts per million, and you can see on the left scale, it goes from 0 to 8,000, and you can see what the blue curve does over time. Right at the base is a red line, and that's to refer to as mass extinction. Anything between 150 parts per million or 170, 180. Anyway, that's that line. But what is clear to see is carbon dioxide levels, there's a downward trend from that high up at nearly 8,000, 7.5, and it spiked through time. But where we are now is near reaching a dangerous level of extinction. So that's a fact, and that is shown. Now, stepping back a little bit again, the big driver behind this, and we're just focusing on the younger time, is, and without going into detail, this was our wandering continents. This was 800 million years ago, and Rodinia, and you can see how these continents walk their way over the globe. And with that wandering process, they go south or they go north over poles, over hotspots, over this and that. So always generating energy, CO2, etc. And life evolves during that period. Right, stepping to pretty much to today. And that's what I show you on there. Top is, as I mentioned, it Earth's internal engine. It hasn't stopped, it's still ongoing. And as mentioned, the sun provides our external energy and heat in a big way, but Earth itself, with its central core up to whatever the temperature is, 4,000, etc., is very hot, creating, escaping gases, and as we call it, the Earth is breathing out in many ways, but surely also carbon dioxide. How much? We've got a slide later on. But these are driven by mid-ocean ridges and hotspots, and specifically I've got a heat flow diagram there. So if you can take your eye across and match them, that is the Atlantic Ocean ridge, and that is coming across there on the left. And we've got these subduction zones along South America. But look at the red, serious amounts of energy, heat, as well as gases coming out. And this is an example of a mid-ocean hydrothermal vent along these mid-ocean ridges, emitting carbon and carbon dioxide in many forms. This is referred to as a black smoker. Carbon dioxide hasn't just been with us since we came along. It's been part of this engine that we're living. That's another example of flood basalts. And I'm just stepping back to showing you one or two examples way up in Siberia. That's the Siberian basalt, and we can see the amount that's been released. And with each of these basaltic events, again, gases. There's the in India, over India is the Deccan. I just get the mouse on the screen here. That's the Deccan. And then I get closer to home with South America. That's a Paraná, and on our side in Namibia, the Etendeka, etc. But then it's ongoing as we speak. And I was very fortunate when I worked in Ethiopia in quite a few areas to get up into the Afar Triangle. Can you believe we were looking at whether we should apply for an oil license? However, and the reason, if you go all along the Central African portion, through Lake Victoria, through down to Lake Tanganyika, there's plenty of oil along this. You can see the weakness as I put it in there. But in the Afar, there's current activities taking place, and in the Daniken Depression, we've got clues about different lives, microbes that live in these environments, organisms that thrive in extreme environments. So life is very able to survive, but these are all conditions that will kill humans and animals. Right. Another engine for us is, as we've put it there, the climate engines and the drivers. So our oceans, surely you can bring up cold water from the poles up to the equator, and it swings back again. And that's dealing with continents, the wandering continents, the complexity of all of this. That's a picture of today. And the same, our wind belts. They've also been circulating air, bringing air around, whether it's oxygen or CO2. And then just at places, all of these specifically hit big mountain belts. Mountain belts has got a lot of internal heat and energy, but not only that, also our winds and climate affected by these high belts. They move along and they change through time. What I've given us then here is, if we put climate change into the periods of ice age, the top bar takes us again 4.6 or up the top down to the last 540 odd million. I've zoomed in at the base for us. So in blue is different ice ages. The one I showed you an example of from Northern Cape and Namibia fits in up there. However, let's focus on this diagram. We've got a couple of plots. Again, my stippled line hiding in the back is CO2. So if you recall, we had a red bar dropping there, and we had another red bar dropping down here to low levels. But over at the back is a temperature, short-term averages and long-term averages for oxygen and temperatures within the Earth. And not strange, but it is a fact that those events whether it's called hot or cold above, it really doesn't mimic the CO2. I've put glacial periods, it's in the bars below there, through that as well. Okay, and they tie in quite a consistent way with the curve dropping at these levels. However, CO2 at times, but not always. There's been the big events in the Permian Carboniferous. Right. So just wrapping up from my side briefly, then is we looked at the dew-based sources as discussed, and it's now over to Ian to take us through the processes.
Thank you. Good morning. There is part of the narrative that we've been exposed to relentlessly in the media over the last 15 years, that nature is perfect, that man has come along and stuffed it up. Nature is not perfect. Nature is a compromise. Nature is makeshift. Nature is opportunistic. If we look at photosynthesis, it arose unequivocally. There is evidence that it is older, but it was certainly around about, excuse me, 1.85 billion years ago. It evolved, but it did not have to evolve. That it wasn't an inevitability. It evolved because there were two resources freely available. One was sunlight, one was carbon dioxide. Carbon dioxide at the time was in the region of 7,000 parts per million. It is currently about 400, and it got as low as 280. When photosynthesis evolved, it didn't know if it was going to last that long. It couldn't know. It's a random blind process. If there was no carbon dioxide renewal from the mantle, from the oceans, from volcanic activity, sooner or later, we were going to run out of carbon dioxide and the whole process would have come to an end. Fortunately, because carbon dioxide releases oxygen and free oxygen became available, another process could evolve, and that was aerobic respiration, the use of oxygen to burn carbohydrate. So photosynthesis and aerobic respiration is the same reaction either way. A nice balance, except it's not in balance. What happens, and mainly in the surface of the ocean, is you've got gazillions, literally, a number times 10 to the power of 25. That's an unbelievable number of microscopic but complex life forms that photosynthesize. When they die, and they turn over a generation approximately once a week in good conditions, when they die, they start to fall to the bottom of the ocean. Most of them are caught on the way by other forms of life that use them as a nutrition source. But some don't get caught and they fall to the bottom of the ocean and they're incorporated into sedimentary rock. There is not much organic carbon in sedimentary rock, but there is an awful lot of sedimentary rock. And a Harvard geologist by the name of Robert Berner calculated that if we burned all at once every fossil fuel available on this planet, we would reduce the amount of oxygen. Remember, the free oxygen is there because of the carbon that was lost. If we burned all that fossil fuel, we would reduce the amount of oxygen in the atmosphere by between 1 and 2%. That is how much carbon gets lost to the system. Part of the I call it the catastrophic global warming narrative, is that nature is perfect and that we've got to learn to live in harmony with it. Nature isn't perfect, and I don't think we live in harmony with it. We certainly need the environment to survive. We need the oxygen, we need the water, we need the green plants, directly or indirectly, to live. But whilst we need it, it's doing its level best to kill us. Earthquakes, landslides, volcanic eruptions, tsunamis, floods, droughts, predators, pathogens. We're not here because we live in harmony. We're here because we're able to survive despite nature to an extent. And I think our relationship with oxygen illustrates this beautifully. I think everybody in this room can agree that if we didn't have any oxygen, things would get tricky. At the same time, it's fairly well demonstrated that oxygen, as a result of our use of oxygen, and bear in mind that oxygen is a highly toxic substance. The action of oxygen on our body is exactly equivalent to the action of radiation. It produces the same radicals, destructive radicals in our cells. Our bodies have learned to cope with it, but it's not a perfect process. And it is fairly well demonstrated that as a result of using oxygen to produce energy, has resulted in the evolution of sex, aging, and death. Now, sex apparently is quite popular. It seems to have caught on. But aging and death, not so popular. If we look at the Carboniferous period, how do I, where's the arrow? Okay, that dip in the middle. It is the only other period of geological history where carbon dioxide has been as low as it is now. There may be other reasons, but one of the reasons for those low levels of carbon dioxide was because land plants had evolved, and they had in turn evolved the production of lignin, the stuff of wood, and nothing during the early parts of the Carboniferous could break lignin down. Even now, it takes a long time. And so trees grew, trees died, trees fell over, but they didn't rot. Eventually they got buried, and that's why we have coal, gas, and oil. Fortunately, at some time during that period, white rock fungi evolved, and white rock fungi have the ability to break down lignin and restore it back to the system. If you come to the modern era, right at the end there, where the levels of carbon dioxide are equally low, instead of white rock fungi, you've got us. Our proposal is that we may well, by burning fossil fuels, have saved the planet. Because if that downward trend continued to that red line, and bear in mind in the middle of the 20th century, when a lot of the people in this room were being born, the level of carbon dioxide in the atmosphere was about 280 parts per million. At 170 or thereabouts, plants can't photosynthesize, they die, we die. So we were 110 parts per million, or 0.01% of carbon dioxide in the atmosphere from extinction. If we're having nightmares about anything, I don't think it should be about a little warming. I think it should be about the prospect of there not being enough carbon dioxide in the atmosphere. And there we have it again. Just to bang the point home, get to this level, that's where we are now approximately. Get to that level, we're all gone. That's basically what I've just said. If you look at the graph on the right, one of the other parts of the catastrophic global warming narrative is that warming is unprecedented. Well, I don't know, is it? It appears to be cyclical. It appears to be equally steep 400,000 years ago as it is right now. That doesn't appear to be correct. It's not unprecedented. It's happened before and it's happened many times. I think this is awe-inspiring. There are 720 billion tons of carbon dioxide in the atmosphere, give or take. These numbers are never that accurate. There are 2,000 to 3,000 billion tons of carbon dioxide locked up in the biomass, the living world. There are 100,000 billion tons of carbon dioxide, so it is estimated, locked up or not locked up, present in the mantle. That carbon dioxide is 100 billion tons of it is slowly and remorselessly leaking into the atmosphere. And when I hear people say that, no, you can't blame the rise in carbon dioxide on volcanic activity. We know what's going on with volcanoes, sure we do. The ones that stick up down there, we haven't got a clue. Not a clue. Okay, this one is just really, again, banging home the fact that carbon dioxide has been remorselessly declining over geological history. This one I think is extremely interesting. During the COVID pandemic, there was a rapid reduction in the amount of carbon dioxide being burned off through fossil fuels. And yet, although the emissions dropped by an estimated 27%, there is no visible change in the carbon dioxide readings taken at the Mauna Loa Observatory in Hawaii, where the international standard comes from. So if we reduced our emissions by 27% for going on 2 years and there was no change, what took its place? Where did that carbon dioxide come from? Because it kept going up. We're not responsible for all the carbon dioxide increase on the planet. We're certainly responsible for some. And that just shows the increase in carbon dioxide since the start of the Industrial Revolution. This one shows the correlation between the carbon dioxide levels in the atmosphere and mass extinction events. Or does it? I can't see a correlation. We're told that we're in the 6th major extinction. If we are, and I question that, then it's got nothing to do with carbon dioxide. It's also probably worth noting that if you take oceanic islands out of the extinction picture, and oceanic islands are particularly vulnerable because evolution takes place in isolation on them, and they're particularly vulnerable to the introduction of foreign species, because birds lose their ability to fly because they don't have to, and so forth. If you take the extinction rates on oceanic islands out of the numbers, it's just background extinction. I'm not saying we're not responsible for some of it, but it's not catastrophic. I'd like to come back to the benefits of fossil fuels. What we hope we've demonstrated is that if carbon dioxide, clearly the processes that take carbon dioxide out of the atmosphere, mountain building and weathering of rock, biomineralization, the locking up of carbon dioxide in mussel shells and coral, for example, the loss of organic carbon in the sediments. If that continued unabated, we would eventually go extinct, unless some lucky geological, another outpouring of basalt. But that wouldn't go down well with the people who are living around. On the other hand, the benefits of fossil fuels, let me put it to you this way. Before we learned to burn fossil fuels and use that heat to produce energy, to do work, people had to do that. And life was pretty bloody miserable for the vast majority of people on this planet. It's no coincidence, I think, that slavery and the Industrial Revolution occurred more or less in synchronization. We like to kid ourselves that slavery was eventually banned because we suddenly saw the heinousness of it. But the other reason that slavery was banned was done away with because, well, frankly, we have machines to do the work. If we lose the ability to power machines, we're going to have to go back to some form of slavery, serfdom, call it what you like. People are going to spend their lives in back-breaking labor just to survive. One more point I'd like to make before handing back to John, is John worked for oil companies, and I can hear somebody say, aha, promoting the oil industry because he's got a vested interest. This is often an accusation lodged at people who express skepticism about catastrophic global warming. During the last 15 years, the United States government has spent $1 trillion on climate. That money has gone to academic research institutions. That money has gone to subsidize solar power and wind power. That money has gone to subsidizing the production of electric cars. I put it to you that a man like South African-born wonder boy Elon Musk, who is one of the richest men on the planet, and the reason that he's one of the richest men on the planet is because he manufactures and sells electric cars. The reason he's able to sell electric cars, which are enormously expensive compared to internal combustion engines, human cars, is because people are worried about catastrophic climate change. So don't tell me that there isn't hope. If there's one, we have created in the United States alone, let alone Western Europe, Australasia, let alone all the foundations like the Rockefeller Foundation, which are pouring money into climate change. Don't tell me that people don't have an equally vested interest in pushing the narrative for their vested interests. The greed works both ways. John,
Yeah,
yes, back to you.
A short interruption and then Jan will continue. Not on a soapbox, but right. A barrel of oil, and can we live without it, yes or no? What I show you there is a barrel of oil or 42 gallons, you will take 160 liters, creates 75 liters of petrol. There you can see the other outcomes or what gets out of a single barrel. Heating oil, jet fuel, bunker oil, LPG, liquefied petroleum gas. But then the last one is the petrochemically derived products. And I've just taken out that, I mean, they count plus 6,000 of these items. I've just lifted 550 out of them. But and I've under there's lines under some of those. Motor oil, bearing grease. You can have an electric car. Right. So we mentioned bearing grease, battery cases, for instance. I mean, it's all derived from some petrochemical input. Fertilizers, candles, water pipes, and the list just goes on, cell phones, etc. But then in italics, I've listed out other few aspects, and these are closer to the body, so to say. Right at the end there, it's tubing, syringes, blood bags, sample tubes, protection, gloves. It just goes on and on and on. In the medical world, capsules, vitamin capsules, etc. It's got an aspect of or hydrocarbons in it, and Jan mentioned that and about this renewable, I call it a farce, and I managed to pull this out, and it's based on data 3 years ago. And the statement says to replace, this is power generating facilities run by oil, gas, or coal, and a bit of nuclear. That's nearly 46,423. If the same generation is required from power stations run by wind, solar, hydrogen, it's at least more than 10 times. That's got to go up to 568,000 power stations. So the greatest challenge, we believe, and it's quoted there from Crichton, facing mankind is a challenge of distinguishing reality from fantasy, truth. So part of the truth is exactly there, 46,500. It's got to be replaced by nearly over 500,000 of still not well-defined generation sources of energy. So, and again, we've told that it's probably ridiculous to suggest that the benefits of increased carbon dioxide in the atmosphere outweighs the negatives of, as we illustrated, a mild warming that we're going through. And that's just the natural process happening in Earth. Right. You want to come and summarize for us a couple again, if need be?
All right. I think the points that we're trying to make is that there is no long-term correlation between CO2 levels and global temperature. It was pointed out, I think, by the Australian geologist, what's his name, Clymer, that if you start your chart in about 1850, yes, we're in a period of global warming, no doubt. If you go and take your chart back to the medieval period, or further back to the Roman war period, or further back to the Minoan war period, we're in a period of cooling. That's what the trend line would show. So perspective matters. The short-term correlation, which there seems to be between carbon dioxide and temperature, is probably a coincidence. It has been colder in the past with high levels of CO2. It has been warmer in the past with lower levels of CO2. The Carboniferous, for example, was a very warm period. The Earth started to warm again after the Little Ice Age in about 1850. Carbon dioxide levels generated by man only began to be significant around 100 years later. How do we account for the temperature increasing from 1850 to about 1950? It was certainly warmer in the medieval warm period and the Roman warm period, where we have written historical records of, for example, grapes being grown on the Scottish-English border, which you'd have trouble doing right now because it's not warm enough. We have written records of grapes being grown higher up the Alps than they are now. We have melting glaciers in North America that are revealing trees, the stumps of the fossilized stumps of trees, which we can carbon date, that clearly show that trees were growing about 200 or 300 kilometers north of the current tree line, which is temperature determined, in the recent past. The whole catastrophic global warming narrative is based on the fact that 0.04%, or a molecule that makes up 0.04% of the atmosphere, carbon dioxide, inflicts upon water vapor and other greenhouse gases a thing called radiative forcing. It may be true, it may not be true, but there's absolutely no evidence. Not a shred. Carbon dioxide is still increasing at a fairly steady and constant rate, and yet the temperature readings in the troposphere are static and have been now for about, I think, 11 years. Just like to take a few moments of your time to talk about climate change propaganda. I would call them lies. I think they're blatant lies. Let's take a few at random. Polar bears, an icon of the global warming lobby. We see film footage of starving bears. Well, no, that bear was actually dying of cancer. Polar bears are just fine. The Great Barrier Reef is dying. The gentleman by the name of Dr. Peter Ritt, at the University of James Cook University. James Cook University in Australia was effectively fired for suggesting that the barrier reef was fine. It's fine. The bleaching that took place as a result of a series of tropical cyclones is basically recovered, and the Great Barrier Reef is actually expanding to the south. Not even the IPCC have the courage to say in their latest report, number 6, I think it is, that there is an increase in extreme weather events. Although every time you pick up a paper, you read about an increase in extreme weather events. There is no sea rise acceleration. It is steady at about 30 centimeters a century. Tropical atolls are not being swamped by the rising seas. A gentleman by the name of Charles Darwin, who was sailing around the world on a ship called the Beagle in the early part of the 19th century, actually figured out, he was a clever lad, figured out that tropical atolls grow upwards. As the seamounts on which they're growing sink into the ocean, the coral grows upwards. Well, they're still doing it. And in fact, recent research has shown that these tropical atolls, many of them, are not only not being swamped, they're actually getting bigger. There is no ocean acidification. It is absolutely impossible that anything like the concentration of carbon dioxide that is possible in our atmosphere to get enough partial pressure, to get enough carbon dioxide into the ocean water to make it acidic. Yeah, it may be less basic, but it's still basic. We're always told about heat waves. Europe had some quite severe heat waves last summer, and so many people died. Not nice, not pleasant, but deaths from cold in any year outweigh deaths from heat-related sources by a factor of 20. Cold is way more lethal than warmth. Warmth, in fact, think about Antarctica, and think about the tropical rainforest. Where does life thrive? Not in the cold. The planet is greening. That comes from NASA. And NASA is fairly famous for being a very strong supporter of global climate change. The reason it's greening is because the higher levels of carbon dioxide in the atmosphere means that plants can get more carbon dioxide into their tissues through their pores faster, so their pores are open for less time, so they don't lose as much water. Desertification is reversing, crop production is increasing. And the 97% consensus, there isn't one. That figure comes from a paper written by a guy called John Cook, who was a New Zealander, who very sensibly left New Zealand. And his name Cook is, I don't know, it's very appropriate because he cooked the numbers. Polar bears.
We pretty much used our
Okay, very quickly. I love this quote. We were 5,000 strong, and then came climate change, and now there's only 25,000 of us left. Anybody see anything extraordinary about unprecedented change there? And finally, well, I've already covered that point, so okay. I can call it quits.
Thanks. We're getting to the stage of bringing in where the world has been and where the world has come to, and this is all driven by, in a big way, energy. If you look at 1992, green is the Western world, where they were. If you look at today, only 2 of them still, and this is based on countries with highest gross domestic product. If you look at, again on the right, you can see the Asian countries have really got themselves up there, coming from nowhere in 1992. And we read and we know how China is really investing and putting itself into fossil fuels of different sources. Going to skip that, that's detail like how much a wind turbine contains, half a ton of nickel, etc., etc. But more thoughts. I've got 2 or 3 slides really bringing things home as where would we South Africa find and get our own oil and gas from. The white dots is potential well drillings that's coming up in the next couple of years. The greens is big finds on the Namibian side, recently by Shell and Total. Drilling happening as we speak, both talking about elephant size. That's billion-barrel field. And it's been mentioned already in oil and gas terms, the biggest ever discoveries, not only for this year, but over the last probably 10 years. That's happening just off our border. Geologists got something quite simple. You just follow the trend. Just look at our mountain ranges. You can see the white dots going into the South African offshore. The crosses are where seismic was stopped. Okay, that's another story. I've just got a picture again. That's a detail of Namibia, and that is what shows up on seismic on the South African side. Cape Columbine there, so referred as the Orange Basin. So the Namibians has pretty much opened the northern part of this basin. It extends along our west coast. It's all deep water. The Shell well was 2 kilometers of water, and the Total well was a world-breaking 3,032 meters of water depth. So it's frontier, but hydrocarbons in excessive amounts. Off Mossel Bay, Plettenberg Bay, discovered 3 years ago, is vast amounts of gas, and the outcome of those gas accumulations would be, and there's, as we speak, an application for development of this. And so there's Plet and there's Mossel Bay, the discoveries. All this that's required is a pipeline of about 70, 75 kilometers that will tie in with current PetroSA or Moss gas facilities, and it will go straight onshore. That gas will get the Mossel Bay gas to liquid plant that produces about 35,000 barrels of oil a day at peak back working. And there's also a couple of gas to power, gas combined cycle facilities that can feed off that gas off our own coast. And that's happened on the 17th of April, so a couple of weeks ago, whatever ago. The Department of Mineral and Energy granted approval for Total and Shell to drill 5 wells in that yellow box. It's, again, where are we? Cape Agulhas, Cape Columbine over there, Hermanus in the middle. So the distance offshore is anything between 60 and 170 kilometers. However, what is quite crucial about where they're targeting to put wells down is that is the 1,000-meter water depth, so a water column of between 1,000 and very likely 2,500 meters, way out in the ocean. They are set to do 5 wells, with the first one end of this year, early next year, and that's the time with weather seasons. Otherwise, it slips into the following year. But just to stress home, finally, is in that yellow box is a massive 10,000 square kilometers 3D seismic survey that was acquired January to April 2020, so 2 years ago. Nobody flinched on it. It happened, and I've studied the technical reports, but more the environmental aspect of that survey, which is a must for the company to submit. Not a single damage to any marine type of life. So I think that's in short our combined story in many different ways. Thank you, guys and ladies.
Any questions?
My name is William Klingenberg, and I do not have a question. I simply want to thank all the 3 gentlemen for the in-depth scientific approach that has, I think, been confirmed in the scientific community over many, many years. However, if we could get the narrative killed and assist, because when we go out of here, we have forgotten not only 50%, but most probably more. However, like in belief systems, we must live it, meaning Earth warming. To pull out a little card, and I hope we can get something in writing geological will say CO2, cause and effect. First of all, we tell them CO2 is not the cause, it's the effect. Number one, how much CO2 are we getting out of the atmosphere? How much do we get out of the ocean? And then the death of polar bears, incidentally, was a good one, but all the other summaries before, the barrier reef is not dying, or other issues, we need numbers. That is important. You know, I say, no, the polar bear is not dying. How do you know? Show me. Well, the last step was an important one. And so it goes with CO2, that we need it. It's almost brushed through. And the underlying, now you can call me a conspiracy theorist, the narrative of Earth warming and we are the culprits has got one reason only: to come to tax system, to fuel tax system, to eco tax system. In other words, this car has got 200 odd ppm of CO2, this one only 150. So we must go for the 150 and we must pay for it. So the summary is, I don't know how you're going to disseminate this information, but in the end, like 10 commandments in the Christian spirit, we have 10 points, cause and effect, CO2, how much Earth, how much from the atmosphere, how much from the ocean, what do we need? And I mean, the levels you pointed out that, by the way, if we come to 180, most probably we are all dying here and not anywhere else, that we are close to extinction. So it's just the opposite what is produced in the narrative. That's the message I want to get across, so that we can stand upon and live it and simply say, wait a minute, check this out, check this out, check this out. The basis of all this, obviously, is your scientific research. That goes without saying, but that's the proof. Now we condense it so that we can talk as non-scientists about the effects. That's all. Thank you.
And we're going to get you to help us put it in. Right, more questions.
Thank you very much, John and Ian. Very interesting, thought-provoking. What troubles me is that you had 500 million years slot and you showed us the decreasing temperatures and CO2 levels, etc. But us mammals, we only the last, 100,000 years or so. So are we not adapted to a very small sliver of where we can fit in? So that is really my question, is not so much, I quite accept what you said, but isn't there, if we go up with 3 degrees or 4 degrees, which we seem to be going, isn't it going to be so difficult for mammals and humans to survive? That's the question.
Peter, I think my shortest reply to you is that I can't speak for mammals, but I can speak for man because I kind of is one. We live in the tropics. We live in the Arctic. We live on the tops of mountains. We live in deserts. We're a very adaptable species. As the planet warms and as it cools when it comes to that, animals that are mobile simply move. They go up mountains, they come down mountains, they go north, they go south. 2 or 3 degrees, I mean, for the people in New York, I would have thought that would have been great news. More than that, I can't say. In answer to what's behind it, I don't know. I think one of the things that are behind it is the capture of academic institutions in the West by people with a distinctly anti-capitalist viewpoint, and the destruction of the fossil fuel industry would be the destruction of industrialized society. That's for my money.
Okay, I mean, maybe we can add more. And I think the first point goes back to the question just asked by Gillian. And hi, Gillian, thanks for participating. It just goes back to, I think, politics, big money, obviously, vested interests, like also mentioned about the EVs and our own South African entrepreneur. I think the other thing, and hence the reason for this group, the OGG, is that we as geoscientists and geologists and professionals have been very poor about selling, advertising, marketing our expertise and our, all the good things we do. So to me, that's one of the biggest problems. And I think if you look at South Africa and its history, sadly, we've had an amazing mining industry, and whether you like it or not, it basically developed this country, whether it was Cecil John Rhodes in diamond mining, and that capital was then created and used to develop the gold mines, and the hospitals and the roads and the infrastructure and everything else. But unfortunately, when you get out into communities where obviously silicosis is still a problem, where there've been at one stage we killed a miner, typically a black miner, for every ton of gold we mine. So when we mined 600 tons of gold a year, we killed 600 people, and those legacies stick. And so we need to combat that, because mining's not going to go away. In fact, if we want, or if we pursue, all the copper we need, all the lithium we need for batteries, everything else, we'll need more mining rather than less. So my plea, and that's why we have a series of programs. Mike DeVittia lives in Kleinmont, and John have been very active in Harold Porter Gardens, exposing young black disadvantaged kids and white kids to geology and rocks. That's in a sense what we are doing. Mike Dormer with his wonderful Earth Age display in Gansbaai, go and see it. It's in the Penguin Sanctuary, and it depicts a lot of these events that have been talked about. So that's really, I think, where we've got to start to address, the narrative that, climate change is awful, it's going to happen, we're screwing up the atmosphere, etc., etc. But it really, I think, goes back to us and getting the message across to the positive sides of, obviously CO2, but most of all mining. I mean, if we hadn't had mining and the Industrial Revolution and good old coal, as dirty as it is, we wouldn't have had steam trains and engines and bridges and iron and steel and all those things. So that's my comment, but maybe there's some other comments as well. Michael?
As a Hollander, I keep quite a keen interest on what's happening in Holland. And I think you're absolutely right with putting it in perspective.
Talk to the people as well.
The positive side and the negative side. And global warming is on our doorstep, but we have to get the facts right. And I was looking at the sea level rises in the last few months, actually, globally, and there is definitely an increase in sea level rise. So we've got to just make sure that we get these facts right, and there's a lot of evidence to support that, and particularly in Holland, where they have a keen interest in protecting the country. They're looking at this very carefully and making sure that the dikes are built up and so on with time. So yeah, a great talk. And I agree that we should try and put it in perspective so that people understand it. We just have to make sure that we get the facts right on some of these things.
Mike, is that sea level rise, is that more than the 30 centimeters per century that was adopted?
It's double now almost.
Double.
Isn't Holland sinking?
Thinking.
Okay, any other questions? We've had a long session, and thanks for your staying power. And thanks to our online guests as well. Last question or two, Henny, you've got any there?
I'm just going to comment here from Nicolette, saying really great talk and thank you for it. It's more a comment, the issue of CO2 is overinflated. We should rather look at a pollution that endanger our environment and the negative impact of pollutants. Also wrongful utilization of resources. Numerous times the carbon footprint of an electric vehicle was shown to exceed that of a petrol engine. Hope we can get this presented as the next talk on YouTube and even proper scientific paper. It would be great to use as a tool to challenge the narrative.
Thanks. And just my last comment, one of the things we will be doing is organizing more field trips. You know, never forget that those of us that live down in Hermanus, you guys in Onrus are kind of buffered and live up the hill. You know, we live on an old beach, a 30-meter beach. Those people who lived in the caves and go there, it takes a bit of scrabbling to get to the caves, but most of you are still quite good on your feet. And I include myself there as a senior citizen. But it's a wonderful locality. There's been some great archaeology. It's very well annotated. And the people who lived in those caves back at that time actually would have walked, 4 or 5 kilometers down into Walker Bay to find mussels and crabs and stuff on the seashore line. So, you know, we've got this wonderful, or these wonderful examples of sea level change, climate change in our backyard. And we've had previous trips there, particularly with a wonderful young girl called Hayley Cawthra, who is young and full of good ideas and expresses herself very well. Hayley's dived, for example, she's a geologist. She's dived on the Augulus Bank. We've all heard about the Augulus Bank south of Augulus. That Augulus Bank is just an old drowned beach. So, you know, she's been down there to see how it looks under the water. So here in our backyard, we have wonderful examples of climate change, sea level going up and down. And please make sure, if we don't have your contact details, those of you that live in this complex, get them to Henny or Annabelle. We have a monthly newsletter, and we will, in fact, on the 19th, 21 of May, do a field trip with Sean to Augulus and see the geology, you know, east of Khan Spy. And if any of you would like to join, you're most welcome. Okay, but thanks for your presence and joining the breakfast.